Good afternoon, learners, and welcome to Dr. D.R. Patil Vidyapith Center for Online Learning. I'm a faculty for this course, that is OMB AIML 303 and OMBBA 305, that is Performing Analytics with Python. So, learners, in this session, we are going to learn about unit number 4, that is Introduction to Data Understanding and Pre-Processing. But before I could proceed, please confirm in the chat box that I'm audible and my PPT is very much visible to all of you. That is unit number 4, Introduction to Data Understanding and Pre-Processing. Am I audible?
Yes, you are.
And is my screen is visible?
Yes, it is.
Yeah, thank you for confirmation. So in this session, we are going to learn about understanding the data and how to process our data and how to build a model. So the first thing is that we need to know, if you want to build a model by using Python, then you must have the skill set in order to analyze, in order to build a model using Python. So that we call as a domain knowledge. So basically, in data science, domain knowledge is used to refer the general background knowledge of the field or the environment to which the methods of data science are being applied. So for what domain you are applying the data science methods or tools, that we refer as a domain knowledge. And if you talk about specifically about the domain knowledge of data analysis in Python, then we refer to the specific areas of expertise and tools which are required or within the Python programming, within the Python environment, that are commonly used for data analysis tasks. So what are the Python programming tools and techniques are used for data analysis tasks that we need to know? So that we refer here as a domain knowledge for data analysis using Python. So in a simple sentence, it means that I need to understand, I need to have the skill set of Python, the tools and techniques which are used in Python, especially for data analysis task, especially for building a model. So that we refer as a domain knowledge in specifically if you talk about in terms of data analysis using Python. So the knowledge of Python, the tools, the techniques, the functions which are required, the expertise, the skills which are required for building a data process or building a model or for data analysis is very much important. So here is an overview of the key knowledge domains that we require in order to perform data analysis in Python. Here, I'm explaining theoretically these all the steps. After that, I'm going to give you a practical example of how to do all these things, how to perform data manipulation with pandas, how to create data frame, how to load. I think I have covered this. That is how to create a data frame, how to load the data, means what, how to read the data, how to clean the data so that my data is consistent, so that there are no duplicate values, there are no missing rows. That comes in data cleaning. That I have already explained this in the previous chapter, practically also. But again here, for the sake of example, at the end of once I complete all these steps, I'm going to again explain how to create all these things practically. So basically, if you want to build or if you want to do a data analysis in Python, so basically, you must know how to create a data frame that we do basically with the libraries of pandas. So here we use pandas library for creating a data frame. After that, once you create a data frame, we need to load it. We need to read it. So how to read that data frame into our Python program? What are the functions that we can use it for reading it? Isn't it? So for example, pd.read underscore, that function that we use in order to read the data set, isn't it? After that, we need to clean the data. Cleaning means what? We need to check whether my data set consists of missing values, whether my data set consists of duplicate values. So that if it present, if the data set is having null values, missing values, duplicate values, I need to remove it. I need to find out and I need to remove it. Why? Because whenever you are analyzing the data, your data set should be consistent. Your data set should be accurate. Otherwise, these missing values or the duplicate values can impact the overall performance of your model, the overall accuracy of your model, or the overall accuracy predictions of your model. So that these missing values, the duplicate values or anomalies will impact on the overall performance of your model. So that's why first here we are preparing the data for data analysis, isn't it? They're called as pre-processing. Before actually I'm building the algorithm, I'm making the data clean, accurate, consistent, so that after once the data has been cleaned, then I can go to the next step, that is of building the model. So cleaning of data is a very, very important task. Then filtering the data. See that when you take a data set from external, isn't it? So for example, I'm taking the data as customer.csv. But in that customer.csv file, you may find some features, some columns which are not relevant for your data analysis. So for that, I need to filter out. I need to remove those irrelevant columns or irrelevant features from my data set. That comes under filtering the data. Then sorting the data. We need to sort the data in either ascending or a descending order, whatever the requirement of your application. So once you sort the data, then the next is a data transformation. Data transformation is also a very, very important thing in data analysis. When I'm using machine learning algorithms, my data should be present in a numeric one. All the values of my data set should be in numerics. But suppose that if some features contains a categorical data, such as male, female, married, unmarried, isn't it? So these are categorical data. For example, graduate, undergraduate, or postgraduate. So such a kind of categorical data has to be transformed into numerics. So by using the methods, using the functions, so for example, one-hot encoder, we can convert the categorical data into numerical one, isn't it? So again, it is very, very important that if your data set contains a categorical data, we need to convert that categorical data, that categorical features into a numeric one. So for doing that, what function I need to use? That I should know. Then only I can use it. Then grouping and aggregation of data. After that, we need to merge the data, and join means what? So in some cases, we need to extract the data from more than one data set, and we need to merge it into a single data set. So how to do that? How to merge and how to join the data? What functions are required or what functions are used for the tasks of merging and joining the data. Then how to work with the time series data as time series data is also very important in data analysis. And the last but not the least is the data visualization. So when we visualize the data by using the different plots, scatter plots, box plot, we can explore the characteristics, we can explore the features of the data set. We can get the insights, we can get the patterns of the data if you visualize, if you present your data by using some plots, by using some graphs. So what visualization tools, which library I need to import, and which kind of graph that I need to use here in order to represent my data set graphically. That also I need to know if I want to make a data analysis using Python. So if you see that these are all the tasks that one can perform in a data analysis. If you want to perform a data analysis, if you want to get some insights from your data set, if you want to make some predictions from your data set, if you want to get some insights, some inferences from your data set, these are the basic tasks. But here, I'm talking from the perspective of Python programming language, how I can implement all these tasks by using Python library or by using Python code overall. So that we will learn in this session. So am I audible to all of you? And the content that I have explained up to this point is clear to all of you? Any questions regarding this point, up to this point? Yes, Juvenuso, Jonathan,
Yes, sir,
Alfia,
it is.
is it clear to all of you?
Yes, sir.
Yeah. So now, another important thing that I need to know here is that when I say a data set, or when I say a data can be provided, or data can be found as structured and unstructured. So now what do you mean by a structured data? A structured data always have some form. It always presented in a format. So for example, in a table format, in an Excel sheet. So you will find that the structured data is always presented in some form, like a table, like your Excel sheet. So that is structured data, which has some structure. But on the contrary, unstructured data doesn't have any structure. Say, for example, a text file comes under the category of unstructured data. For example, images comes under the category of unstructured data. So, for example, audio and video files comes under unstructured category of data. So, structured data refers to the data that is organized into a well-defined format or a structure. Like I said, that typically using tables or databases. So a data which is present in tables, a data which is presented through a database is always a structured data, where each data point has a clear meaning. But on the contrary, unstructured data refers to the data that lacks a predefined structure, that don't have a predefined structure. Like for example, a data which is presented in a notepad, which contains of text, which does not have any predefined structure. It is simply given as a text, simple text, which is often in the form of a text, images, audio, and video files. And here, as a data analysis, this unstructured data is also very important. But at the same time, it poses many challenges to analyze these unstructured data. So as a data analyst, we have to face the unstructured data as well. How we can use the unstructured data, how we can able to convert these unstructured data into the structure that our programming language required, that the data analysis is required. So again, it's a challenge for the data analysis or data analyst to process the unstructured data. Why we need to understand the structured and unstructured data? Because data is available in different varieties, isn't it? It is presented in in the form of a text file, in the form of a audio file, video file. It is available on the internet. It is available in the journals. So now the data is present in different varieties. But at the same time, we need to understand what kind of data that we require. If it is structured, then if that structured data is having a categorical values or what? If it is having categorical values, then I need to convert into the numbers. But the structured data is commonly used in databases or in CSV files. And the structured data will give you, it has been used for decision making, and which will again give you the advantage of competitive advantage. So that's why we need to understand the structured data as well as unstructured data as well. Both data are important. But challenge is more when you are when you are dealing with unstructured data. So now we'll start with the data analysis process, which is a dynamic or a systematic approach to inspect, to clean, to transform, and the model data to discover the meaningful insights, the patterns and trends. So what is a data analysis process? A data analysis process gives you a systematic approach, a systematic way of inspecting the data, cleaning the data, transforming the data, modeling the data to discover the hidden patterns, the meaningful insights, the references, and the trends. And that typically involves several stages. That is inspecting, cleaning, transforming, model building, and getting the inferences. So these steps typically involve several steps. And Python is a popular programming language which provides the tools and the techniques for implementing these processes. So now let's look at them one by one in a fast faster way. First one is the data collection. That data can be collected from various sources, including it can be from databases, it can be from the files, it can be from APIs, it can be from web scraping, it can be from sensors, it can be from anywhere. So nowadays data is available everywhere. So on social platforms to the databases and from the APIs, we need to know what kind of data that I require. Accordingly, you need to select the source. From that, you can collect the data. So for example, collecting the customer transaction data from an e-commerce website, because I want to analyze the customer spending patterns. So now here what I will do, I will select an e-commerce website, and from that I will get the data of the customer so that I can understand the buying behavior of the customer in particular season or in a particular area. So the first step is data collection. Second is, once you collect the data, then you need to clean the data. That is removing the rows having missing values and correcting the spelling mistakes in the data set. So identifying the missing rows or the rows that doesn't have values, or identifying the rows which have duplicate values, that I need to remove them. And again, identify if there are any typing mistakes, I need to identify and I need to correct them. So this is the second step, that is the data cleaning. So for example, here I'm giving the example that how we can perform the first thing, that is first we need to import the pandas as PD, because here I'm working with the libraries of pandas, the functions of pandas, that is of creating the data frame and working with the data frame. So here, first thing first, we need to import the pandas library, and by using the object of that pandas, I'm reading the CSV file with the help of read underscore CSV and specify the file name. So here I'm reading the file with the help of the object of pandas dot read underscore CSV function, and this CSV function, or this read underscore CSV function, accepts one parameter, that is nothing but the name of the CSV file or the file that you want to read into your Python code. After once you have successfully read the content into the Python, the second thing is that we need to find out uh, the rows having missing values with the help of data drop NA. So here the data, what is data? Data is just my data set. Here I have read the data.csv and store into the data set called as data. And now from this data, I'm finding out the rows with missing values, like data dot drop NA function. So this will drop the rows having missing values. So now my data set is free of rows which is having missing values. So now in my data set, I don't have any rows with missing values. Once I execute, or once the compiler execute this statement, then I need to find out the duplicates, whether I'm having the duplicate rows or not. And that can be done with the help of data dot drop underscore duplicates. So first here I'm creating, I'm calling the function that is data dot drop underscore duplicate. So this will just simply remove the duplicates if there are any from your data set. So after that, now once this statement is executed, now I can say that my data set is free of missing values, free of duplicate values. Now I need to find out the data inconsistencies. So for example, if some typing mistakes are there, then I can do that by using the replace function, like as you can see here, that data column, which column that you want to make correction, is equal to data column name dot str dot replace incorrect value with correct value. Suppose that here you want to replace a name with say the name is XYZ, and now I want to replace that XYZ with ABC. So here incorrect value I can give as XYZ, and the correct value I can give as ABC. So here I'm correcting the typing mistakes. The third one is data exploration. Means what? Here I am knowing the characteristics of my data. That is, I'm summarizing the, I'm finding out the features of my data. What is mean? What is mode? What is median of my data? What is 25% of data? That is Q1, Q2, and Q3. All the statistics about my data can be found out with the help of the describe method, if you could remember. So with the help of describe method, you can find the summary of your data, that is the statistics, that is the central tendency of your data, that is mean, mode, median, plus as well as you can also display Q1, Q2, and Q3 as well. So creating histograms, scatter plots, and summary statistics to understand the data distribution. So this is the third step, that is the data exploration. The next step is data pre-processing, where I'm scaling the numerical features so that my data can be bring in a same scale, isn't it? Again, this is very, very important. If your data is not in a standard scaler, then the performance will be impacted. Then the predictions that your model has made, that that could be wrong. So the accuracy level of your model could be go wrong. So it means that we need to bring the data in a proper scale, and that can be done with the help of the mean max scaling and one hot encoding functions. So here I'm bringing my data into a same scale. That is, we call it as a data pre-processing. So as you can see in the slide, that from sklearn.preprocessing, I'm importing the mean max scaler, comma, and again one hot encoder. Mean max scaler is used for scaling the data, while the one hot encoder is used to convert the categorical values into a numerical values. So here I've imported the min max scaler and one hot encoder from sklearn.model underscore selection. I'm importing the train underscore test underscore split so that I can divide the data into training and testing. So here, what is the strategy of dividing the data set into training and testing? See that here, once I build the model, I will train the model with the testing data. So here I will divide the data set into testing and training. Basically, uh, the testing I will divide as 80-20 ratio. 80% of the data for testing and 20% of the data for training. So, and I will train my model with the 80% of the data, that is called as testing of model, or that is called as, we can say, a training of the model. So with the help of the training data, I will train with the 80% of data. I'm training my model. So here I will divide my data set into testing and training data set. First, I will train my model with the training data, that is 80%. So once your model is trained on that 80% of the data, then now I can test, I can check how well my model has learned by providing the 20% of the data. So here, first I will train my model with 80% of data, and after that I will provide another 20%, the remaining 20% for testing my model, how well my model has learned, so that I can compare the result of the actual and the predictions, so that I can check how well my model has learned. So in order to split the data, I am just importing the train underscore test underscore split library from sklearn.model underscore selection, so that I can divide the data into testing and training. Like I said, that we divide the portion of 80 to 20%, 80% to 20%, 80% for training and 20% for testing. So first we train our model with the training data, that is 80% of data. And after that, we check, we provide the testing data of 20% to check how well my model has learned. Now I can find the difference between the actual values and the prediction values. I can find out the difference, that when I provided the testing data, what is the values that I've got, and when I provide the training data, now what is the values, what is the accuracy level that the model has given. So now I can find out the difference between the actual values and the predicted values, so that I can know how well my model has been trained. If the difference is more between the prediction and the actual values, then I can say that my model has not learned well. So if the difference between the actual values of my model, of my algorithm, listen carefully, if the difference between the actual values, the actual values when I give the training data, and the values when I got, and with the when I have given the testing data. So what values I have got when I test my model, and what values I have got when I train my model. So I will find out the difference between the results of these both, testing and training. And if the difference is less, then I can say that my model has learned well, because there is very small amount of difference between the results of testing and the results of training data. But if the difference is more, if it is more, then we can say that my model has not learned well. So here I need to refine my model. So here, first thing first, that I am creating the object of mean max scalar. So how we can create with the help of mean max scalar function. So now I have got the object of mean max scalar with the name of scalar. Now I can use this scalar object to convert the numerical values. I can convert the categorical values into a numerical one, isn't it? So with the help of, as you can see that the object of the scalar dot fit underscore transform is the function that will transform your categorical values into a numerical one. So scalar dot fit underscore transform specify the data set, that is data, and here I can specify the name of the column which contains the categorical values. So for example, the categorical values contains in a gender feature, in a gender column. So here what I will do here, in a single inverted comma, I will specify as gender. Specify the name of the column which contains the categorical values. So this will convert those categorical values, like for example, male and female. So it will give 0 as male and 1 for female. So male is converted as 0, female is converted as 1, vice versa. After that, I am bringing my data into the scale. So here, scale, first thing is that here I have scaled it, that is scalar dot fit underscore transform. Then now I'm using the one-hot encoder to convert the categorical variables into a numerical one. So by using the scalar, first thing here, we have bring our data into a same scale. So here I've referred as category values, but sorry for that. So here the scalar, see that here, scalar is what? Scalar is the object of mean max scalar. So by using the scalar, I am standardizing my data set. Means what? I'm bringing the numerical values in the same scale, isn't it? After that, I'm converting the categorical values into a numerical values by using the one-hot encoder. So first thing first, we need to create the object of one-hot encoder. Now I have got the object of one-hot encoder, that is encoder. Now I can convert the categorical features into the numeric one. So this will convert the categorical values into numerical one, and this scalar dot fit underscore transform data numeric features means what? Here I need to specify the column names for which I want to bring the data set into a same scale, into a standard scale. So that I can specify here in the bracket the name of the columns which are having a numerical values, so that the values in that column can be of all the values in that column can be brought in the same scale. So this is about making your data, bringing your data into the same scale and converting the categorical features into a numerical one. That is step number 4. Now we'll see the step number 5, that is the data modeling. So modeling involves selecting and training the machine learning models to make predictions or classify the data. So now, once you have done with cleaning the data, once you have done with transforming the data, then the next step is data modeling, where we select a particular machine learning model, and after that, we will train the model by using the train data, and after that, we will test the model by using the test data that we have split it in training and testing, that we have divided our entire data set into train and testing purpose. So now, here we are going to use a linear regression model to predict the sales based on advertising expenditure. So here my data set contains the advertising expenditure. Say, for example, the advertising expenditure on TV, in newspaper. So here my data set contains of the advertising expenditure, and based on the advertising expenditure, I'm having the sales values. So here I need to find out the relation between the advertising expenditure and the sales of a particular product. So for that, I'm using a linear regression model to predict the sales based on advertising expenditure. So first thing first, here I will select a machine learning model that here I'm using as linear regression. After that, I will train the model by providing the training data. So once the model has been trained, I'm having its results. After that, I will test the same model by providing the testing data. So now I will check the results of both, that is, what result that I have got when I have trained, when I have tested, when I have trained my model, and what result I have got when I have tested my model. So if the difference is more between the test and train, then I would say that my model has not learned well. I need to refine it. But if the difference is less between the results of testing and training, then I would say that my model has learned well. Now its predictions are very much close to the actual one. So that is how I will interpret at the end of once I will execute, once I will run my model. So here I'm using the linear regression model in order to predict the sales based on advertising expenditure. So here I use the scikit-learn or the other machine learning libraries for building my model. So now I will show you practically that how we can do that. So here, how we can split the data into training and testing. As you can see that here, x underscore train, comma, x underscore test, comma, y underscore train, underscore y underscore test is equal to train underscore test underscore split. Features, what feature that you want to split, what would be your target variable, and what would be the size. So it means that 0.2 means what? Here I want to split my entire data set as a 20% for testing and 80% for training. And random state is equal to 42 means what? The random state will produce, or it will extract the same amount of data. If you run this example multiple times, you will get the same. And you see that what this split will do, this split will randomly pick the data. So if you don't specify the random underscore state, then every time you will get the content of 80% and 20% are different. I'm telling about the rows. The rows of 80% and the rows of 20% that you got is different. After some time, if you execute the same, then you will get another different the data in 80% or 20%. But if you specify as random underscore state is equal to 42, then you will have the same amount of data in 80% and 20%. Means what? The records in 80% and the records in 20% are same. If you specify the random underscore state is equal to 42. That is the use of this parameter. After that, by using the linear regression model, I am training my model. As you can see that first I'm creating the object of linear regression with the help of the linear regression function. Now I represent the linear regression function with the help of model. So now I'm training my model. Here I have built the model. Here I have created the object of linear regression. Now I am training the model, that is model dot fit x underscore train y underscore train. So x will contain the expenditure and y contains the cells, isn't it? X train contains your information about the expenditure about the cells, and y will contain about the x underscore train will contain the expenditure, and y underscore train will contain the cells. So we can say that x is a independent variable, whereas your y is a dependent variable, because your sales depends on the expenditure. So here I'm training my model with the help of model.fit. I'm providing two parameters, that is x train and y train. X contains sales expenditure and y contains the sales. X contains the expenditure on advertisement and y contains the sales. So here I'm training my model with the training data. So as you can see that here, I have splitted the data in X train and Y train. So now here I have trained my model with the help of model.fit. Now after that, I am providing the test data so that now my model can able to predict with the help of model.predict. Now we can see here, I am providing the parameter as x underscore test, which contains the testing data and the result of the model.predict. So here my model has given the predictions. If the if the expenditure on TV, expenditure on newspaper is so and so, then I will get the sales like so and so. So now here I can check the result of both. That is, when I have tested the model, what are the values that I have got, and when I have trained it, what values I have got, so that I can compare it. If there is a negligible difference, again it depends on the application. If there is a negligible difference between the predicted values and the actual values, then we can say that my model has learned well. It has predicted correctly. So I'm just checking that if I provide the training data, then I will train the model. After that, I'm providing the unseen data, that is testing data, to see that how well the model has learned. What is the difference when I have tested the model with providing the testing data, and what would be the values when I have provided with the training data. So we train the model with training data. After that, we test the model with testing data, and we will find out the result. We'll find out the difference between the testing and training. Again, I repeat, if the difference is less between testing and training results, then I can say that my model has learned. Means what? If there is a negligible amount of difference, or if the level of difference is been defined, is accepted to the owner or the stakeholders between the actual values and the predicted values, then I can say that my model has learned well. So this is about making predictions. Now we'll move on to the actual execution. So now if you have any queries up to this point, that is up to step number 5, please go ahead, unmute yourself and ask, or else you can type your questions in the chat box as well. So in the meantime, here I am giving the feedback link for this session so that you can give your remarks, your suggestions by filling up the feedback form. So give me a moment. So guys, have you understood to the part that I've explained here? Are you there in the session? All are in the same page? Any queries, any questions up to this part? It is clear. Solomon saying is clear. Nagaraj is also saying clear. Okay. Anybody else? Okay. Now we'll move on to the practical part. Means what? Here I have talked about the theoretical part. And again here, I have explained the steps by writing the actual code. But here I have not executed the code. So now the time has to come that the time has arrived. Now I can go for testing it or execution part. So please give me confirmation in the chat box that is my screen is visible to all of you. Give me a moment. I am sharing it. The Google Colab.
It's visible, sir.
Yeah. Just wait, just wait. Yeah, this is my, yeah. So this is my Google Colab page where I'm executing my Python code. Yeah. So now we can see that in the first code box or in the first cell, that is from google.colab import drive, because you can see that my data set that is advertising.csv file is present on my drive. Since here I'm executing the example on the web, isn't it? So for that, if I'm executing my model on the web by using the Google Colab, so your data set should be on your web, on the web or a web resource. So now here my data set is in my drive, in my Google Drive. So for that, you need to mount it first. So again, if you're executing this example, first thing first is that you need to have the data set that is, as you can see here, advertising.csv file. Okay, I will open the advertising.csv file so that you can have a view of the columns of the advertising.csv. So now here I have opened it, and again here I need to share it. Yeah. So this is my advertising.csv file. I hope it is visible to all of you. As you can see that I'm having 1, 2, 3, and 4 columns. The first column, the TV, second is radio, and third one is newspaper, and fourth one is the sales column. So what is the database is all about? What is this data set is all about? This data set is all about the expenditure that I have incurred on TV, on radio platform, or on newspaper platform. So when I incur the expenditure on TV, on radio and newspaper, my sales is like this. Again, when I spend for advertisement on TV, this much, on radio, this much, on newspaper, this much, and this is my sales. So here, by using this data set, what I need to, what I'm making a sense here, what I'm trying to find out. Here, this is my data set. So what I will do here, I will split this data set into testing and training. If you have more amount of data for testing, it is advisable. So that's why here I have taken 80% of this data for training. So you should have more data for training and less data for testing. As much data that you can provide to train your model, that will be good, that will be ideal, isn't it? So I have divided this data set into training and testing, 80% to training the data and 20% to testing the data. So now here, I will provide 80% of the data to my model, that is linear regression model, and I will check the results. I'm just here, I'm training my model by providing the training data. I will get the results. Once the model has been trained, now I will provide the testing data, that is 20% of data. Now I will have the results of this testing of the data. So now by using some metrics, for example, mean absolute error or F1 score, I can find the accuracy level of my model. I can find the performance level of my model, how well my model has learned. So for example, here in this example, I'm going to use the MAE, that is a mean absolute error, which will provide me the average absolute difference between the actual values and the predicted values. It will provide the absolute average difference between the actual values and the predicted values. And again, if the difference is minimal, if that difference is acceptable to the stakeholders, I don't need to refine my model. I can say that my model has learned well. Why? Because the actual values and the predicted values, there is a less amount of difference. It means that my machine learning model has predicted correctly. If you spend on TV this much, if you spend on radio this much, if you spend on newspaper this much, then the sales would be 10 point something like 6 units. So whatever difference that you will get, or whatever value that you will get for MAE, that is mean absolute error, suppose that I'm getting 1.47 as the MAE value. So what it indicates? It indicates that there is a difference between the actual and predicted of 1.47 units. It means that your predictions that your model has made is off, is far away by only 1.47 units. In that way, I need to evaluate. In that way, I need to interpret the value of mean absolute error, which is a way of finding the accuracy level of your model, how well your model has learned, how well your model has been tested, or how well your model has been trained. So that you can find out by using some metrics. One metric that I have used here, that is mean absolute error. Again, other metrics are available. We need to check, we need to use the appropriate tools to find out the accuracy level of your model. So this is my data set, and I hope that it is visible to all of you guys. Can you see this data set that is presented in a advertising.csv file, that is comma separated values? So I hope it is visible to all of you. Please confirm in the chat box. Yeah. Thank you. Now we'll come back to our give me a moment. Yeah. So now, is it visible, guys? The Google Colab page. Can you see that? Building. It is not visible. Okay, just give me a moment. I think it is visible now. Is it visible?
Yeah.
Yeah. Thank you. So the first thing first is that you need to mount your drive. Suppose that, as you can see here, my data is in my Google Drive. So this is in Google Drive, isn't it? So in order to get your data into your Python code, you need to mount your drive so that you can refer that CSV file. So the first thing first, that you need to mount your Google Drive if provided that if your file is presented in Google Drive. Suppose that if you're working on your local machine, not on Collab, then you can simply, there is no need to mount your drive. But here, my data isn't present in a drive. So I need to mount the Google Drive by using from google.collab, import the drive. So the entire drive will be imported. So from that entire drive, here I'm importing, here I'm mounting, especially the drive, that is uh, drive.mount in the bracket, parenthesis, single quotes, forward slash, content slash drive, and single comma complete and parenthesis complete. So this will mount my drive. Now I can read the file. So now the first thing first is that here I have imported the libraries which are required, that I have shown in the PPT as well, isn't it? So I imported pandas, I imported NumPy, I imported Seaborn for plotting, for visualization. I've imported the matplotlib as well for visualization. I've imported the train underscore test underscore split library so that I can split. Again, I have imported the linear regression so that I'm going to use the linear regression model. So here I have imported all the libraries, like for example, standard scalar, one-hot encoder, and again I have imported the pipeline as well. So these are the necessary libraries that I am importing in order to build the model. Now, the first thing first is that we need to read, we need to load the data set into the Python code. How I can do that? With the help of pd.read underscore CSV, and in the bracket, provide the complete address of your drive with the file name, that is slash content slash drive slash my drive is the name of my drive. As you can see here, this is my drive. After that, in my drive, advertising.csv file is present. So in my drive, advertising.csv file is present. So here we need to give the complete address, isn't it? As we can see that is absolute address. So now here I have read the data set into my df data frame. So now I can refer the data set as df. So df here stands as advertising.csv file. After that, I need to clean it. So in that, I am finding out whether there are any missing values or not. How I can do that? With the help of is null dot sum. That is df dot is null function dot sum. So this will give me if there are any missing values. This will sum up the missing values rows, and it will give me the missing values information if there are any. So if you can see the data set, you will hardly find any missing values, but still we need to perform this step so that we can ensure that my data set does not have any missing values. Okay. Then the next step is the data exploration. So in that, I need to display the statistics about my data set with the help of df.describe. So the df.describe will give you the information like this. That is mean, STD, mode, Q1, Q2, Q3. Again, you can see that missing values are 0, isn't it? Because here I have checked it. If there are missing values, then I would have got the numbers here. So here I'm finding out the characteristics of my data set with the help of describe function that can be called with your data set, that is df.describe will give you the information that is here I am highlighted. So this is the output of df.describe. Then after that, I am plotting the values so that I can visualize my data on a plot. So for example, I'm using the pair plot. So SNS, as you can see, what is SNS? SNS is the object of C1, which is used for data visualization. So with the help of SNS.pair plot, I am drawing the pair plot, and on that I am displaying the expenses on TV, radio, newspaper, and its sales. So if you execute that, you will find this kind of result, this kind of visualization on your screen, that is on TV, on radio, and on newspaper. On X, you will find X ratio, you will find on X bar, you will find the expenses, and on the Y bar, you will find its sales. So these are the three expenditure and their sales that I have plotted here, visualized here with the help of a pair plot. So this is the result of the code that I have just shown you. This one. So with the help of show function, I am actually displaying the scale, the pair plot on my screen. After that, data processing. So for that, first we need to create data. Here I'm dropping the cells from my data set so that the X bar can contain only cells. So here I'm dropping the cells from my data set. So now after that, Y bar will contain the cells and X bar will contain the expenditure. So here I am dropping the sales column, so that the X bar can contain only the expenditure. Are you getting my point? See that the X train contains both, that is expenditure on TV, on newspaper, on radio, plus sales. But I want only the expenditure on X bar. So that's why here I am deliberately dropping that cells from my X train. So here I'm dropping the sales column so that I can have only features, that is X will contain only the features, X will contain only the independent variables, that is advertising expenditure. Are you getting my point? And after that, you can see here Y is equal to DF cells. So here I'm creating, I'm assigning Y only the cells. So now we can say that X contains independent variables, that is nothing but advertising expenditure, and Y contains your dependent variable, that is sales. Are you getting my point? I hope everybody is on the same page. Why I am dropping the cells from my data frame for X, so that on X I can have only independent variables, that is expenditure on TV, newspaper, and radio. And Y will contain the dependent variable, that is sales. After that, I'm using the I'm using one-hot encoder, I can use it, but since my data set does not contain any categorical value, so there is no need to use one-hot encoder. So I'm just using the standard scaler to bring the entire data, which is in a numeric one, into a same scale, into a standard scale. So here I'm using the preprocessor is equal to column transformer class, and in that transformer I'm giving a name to the standard scaler as num, and here I'm providing the columns for which I want to create a standard data, that is on TV, for radio, and for newspaper. And here I'm saying that remainder is equal to pass through. What is the use of this? So that suppose that if I'm having a column, a feature in my data set which cannot be brings into the same scale. So in that case, that column will just kept it as it is. But there is no such thing here. There is no column, there is no features which cannot be bring down into a same scale, because all these radio, TV and newspaper columns having numbers. So there is no issue with that it is not bringing down in the same scale. But for the sake of security, I'm giving as remainder is equal to pass through. Means what? If there are some columns in your data set which cannot bring down into the same scale, then that columns data will be kept as it is. So that is why here I am using, even if you remove this, it does not matter for this example. Okay, so now once you have performed the pre-processing, that is transformation, that is bringing down or bringing your data into the same scale, or you are transforming your data from categorical values into numerical values, the next thing is to modeling the data. So for modeling the data, you need to split 80% for training, 20% for testing. As you can see in the example here, I have used that X train, comma, X test, Y train, comma, Y test is equal to train underscore test underscore split is the library that I have imported here. And to that, I'm providing X, comma, Y test size is equal to 0.20. So it means that I want to divide the data 20% for testing, and remaining data will be used for training purpose. And random state is equal to again 42. So that every time when you run this example, it will fetch the same rows for 20% as testing and same rows 80% for training. That is the use of this parameter, that is random underscore state. So now here I have split the data. Then the next thing is to build the model. So here I'm using the pipeline function. So pipeline, and in that I am defining the preprocessor and I'm defining the linear regression function. And to that I'm giving a name as preprocessor and regression. So here I am building the model. So this code will create the class with the name that is a model, and pipeline of class will use to assemble many things that will be executed. So here I'm using the preprocessor as a preprocessor. I'm using the I'm calling the linear regression function as regressor. So now I can use this complete as I can represent this complete code as a single code, that is a model. Okay, so now here this is my model. Now I have built the model, that is linear regression model. So after that, once you build your model, the next thing is that you need to train it. You need to train it, isn't it? Like in case of the military, once the people are inducted into the military, they are trained, isn't it? They are trained. So after that, once they are trained, they will that army or that newly recruited cadre will be sent onto the actual war. So in that same way, we have to take it that before actually predicting the model, before the model has to predict for unseen values, I need to train the model. So first, I'm training it with the help of, as you can see, that model is my model which is having linear regression. So model dot fit x underscore train, comma y underscore train. So here I'm providing x that contains my features, independent variables, and y contains my dependent variable, that is cells. X contains expenditure on TV, radio, and newspaper, and Y underscore train contains the cells. So here I'm training my model with X underscore train, comma Y underscore train. So after the model has been trained on the training data, Now I am making the predictions. Now I want to see that how well my model has been trained. So now I am sending that cadre in case of a military onto a war. So for example, I have created a scenario of a war, and into that I have sent that cadet in order to see that how well that cadet has learned during his training period. That I can see that if that cadet will be able to perform the things correctly in that sample scenario, then I can say that that cadet has learned well. So in the same way here, first I have trained the model with the help of training data. Once it has been trained, now I'm testing it with test data, which is I'm providing unseen data to the model with the help of model.predict. Now we can see that here I am providing x underscore test. So here I'm providing 20% of data, that is testing data, to predict. So now give me prediction for this x underscore test data. What would be the sales if the expenditure on TV, radio, and newspaper is so and so? Now you tell me what would be the sales. So if the results of training and testing, if there is a minimal amount of difference, then I can say that my model has learned well, because the predictions are close with the actual values. The predictions of sales are close to the actual sales which are given in the training data. But if the difference is more, then I can say that my model has not learned well. I need to refine it. In that way, we need to interpret the result of this model. So after that, once I have predicted, now model evaluation. So how we can check the accuracy? So for that here, I have taken that is mean absolute error as a criteria. So by using the mean absolute error, that is MAE, I can check the accuracy level of my model. That is how well my model has predicted. So here MAE is equal to mean underscore absolute underscore error. This is a function. And for this here, as you can see that here I have provided the result of test and pred. The result of test are stored in y underscore test, and the result of predictions, as you can see, they are provided in y underscore pred. So now here I'm comparing, as you can see, I'm comparing the results of testing and the results of predictions with the help of mean underscore absolute underscore error. The mean absolute error, that is MAE, will give you the average absolute difference between the actual values and the predicted values. So the actual values are present in y underscore test, and the predicted values are present in y underscore pred. So after that, I can print the result of that MAE. So now I can check the prediction level, the accuracy level of my model. So now, for your sake, one more time, I will execute this example. So here I'm clicking on the run cell. So in the meantime, I request all of you to give your feedback by filling the feedback form. If you have any queries, please go ahead and ask in the session. But you can also give your remark in the feedback form as well. But if your remarks are given in a feedback form, then it will take some time to address. But if you ask your queries in the live session, then it would be easier for me to address. So it is giving me error. Why? Because I haven't run this. So I just need to run this one more time since I opened it afresh. So I need to mount it. Yes, it is asking for Google, connect to Google Drive. Which account? Select the account, email ID, and say allow. Yeah. So now my drive will be successfully mounted. As you can see that it is mounting. Now it is mounted at content drive. Now I can execute one more time. Yeah. Now you can see that it is in a converted into a black color, means what? Everything is correct. So you can see that the result of the describe, the result of missing values, the result of describe, df.describe, the result of the pair plot, and after that, once the model has been learned, once the model has been predicted, now here I'm using the scatter plot to visualize the difference between the visualize the difference between the predicted and the actual. As you can see that plt dot scatter y underscore test comma y underscore pred. So now what y will contain? Y will contain the cells. That is independent variable. So now with the help of this scatter plot, I'm displaying the result of my test and the training result in terms of cells. So as you can see that here, the difference of actual versus this is the actual cells and this is the predictions. Now we can see that the dots are closer, isn't it? The dots are closer to each other. So what this means? It means that your model has learned well. It is not far away from the actual cells, isn't it? How I can say that? Because as you can see, the mean absolute error value is 1.46. So it means that the mean absolute error is 1.47. So in another way, I can say that my the difference between the actual and predicted cells is 1.47 units away, because the cells are predicted in units, isn't it? So I can say that there is a difference. What is the difference between predicted and the actual? The difference between the actual and predicted cells in terms of units is 1.47. So it is acceptable. So now I can say that my model has learned well, because it is just 1.47 units away from the actual units of cells. So this is the output that I can, by using this matrix, that is mean absolute error, I can say that by observing this value, that is 1.47, and again, it depends on the stakeholders. If the stakeholders say that it's okay, that 1.47 mean value or mean EA value is okay, then it is absolutely fine. But if that stakeholder says that no, you need to refine it. So after that, we need to refine the model by using other machine learning functions and tools. So with this, I would like to conclude this session. Before that, George, what you are saying, George? George.kamage@gmail.com. Please Google Colab code to my email. Okay. Okay, I will try to send this entire Google page to your email ID. I will share this drive rather, so that you can have it in your drive. But before that, if you have any questions, please go ahead and ask, or else I would like to conclude the session here. So today in this session, we have understood about the data pre-processing and how to build the model. First, I have explained the stages theoretically, and after that, I have explained the how to build a model by using Python and how to interpret the result of your model with the help of the Google Colab page. Is it possible you to send us the code? Yeah, George Kamanix, I can share the Google Drive to your email ID. So please, whoever wants this code, please send your email ID to my email ID. So here I'm giving my email ID as say anand.irabatti@dpu.edu.in. So this is my email ID. Whoever wants this code, please send your mail or just text me to this email ID so that I can share the Google Drive for this Google page or Google Colab page rather. So I hope that you all people have understood clearly. If you have any questions still, you can write to me to my email ID that I have given here, or even you can reach through your mentors as well. So with this, I would like to conclude this session here. So this is unit number 4 that today I have covered it. So thank you everyone for your joining this session. See you in the next class. Until then, very goodbye for now. Have a great day ahead.